Chapter 12, Part A, Deflection of Beams and Shafts. Example number 3. Let's consider a cantilever beam like what we observe here. We want to calculate or uh, derivate the equation for elastic curve and then calculate a theta at A. So a solution 1 could be determination of elastic curve from the equation of moment. So what we can do about this is if we cut the beam by a length of cut it through by a length of x, and then in such case if we have a complete the whole length entire length of the beam, we have a w naught, and if it just goes by a somewhere before the whole length, something like x, it just goes by something, and that's a x over L W naught, like what you can see here. Mhm. Then if we just convert that a distributed load to a concentrated load, which happens, which applies at the centroid, that's 1/3 from the base, and at the same time, because we cut it through, we do have a V and a moment at the cross section X. Mhm. So let's see how that goes. So summation of moment about X goes 0, gives us a mx. Mhm. So mx, it's a counterclockwise consistent with our positive direction, a minus ra times x, and the intensity of this load is just x over L times W naught, and when you convert it to a concentrated load, that's a half of x over L times W naught times the distance x, which gives you the concentrated force. So that's here. Mhm. And then times the distance, and if you just rearrange the equation, it gives you the equation for mx, which is a negative 1/6 a w naught over L x cubed plus ra times x. By the first integration from moment, we get to a slope equation, and by the second integration from moment, we get the elastic curve or deflection equation. And by each integration, a constant appears, so we have C1 and C2. So let's go back to our boundary condition, because for each of the uh, integration constant, we need a boundary condition to solve it. So if we call a theta equation 1 and delta equation 2, and based on our boundary condition, when x is 0, there is no delta. A is 0, that's A. And when x is equal to L all the way to the B, we have no delta, and also theta is 0 because it's a fixed support. Mhm. So then what A and 2, if you replace A in 2, it just simply gives you, if it means replace all the x by 0, it just simply gives you C2 is equal to 0. And also by replacing B in 2, B is at x equal to L, y is equal to 0. So that gives you a C1. Mhm. If you call this equation A3 and you solve it, it just gives you a let's have this equation and just call it equation 3 based on something based on Ra and C1. And C and 1, this time C, replacing C at x equal to L, theta is equal to 0 in 1 this time. It just gives you a new equation, which we can call it equation 4. And now we can easily see if we multiply equation 4 by a negative L, we can easily cancel out C from both equation and get Ra based on because that's a indeterminate equation by 1 degree. So let's see how that goes. Mhm. So if you rearrange the equation by multiplying the negative L in equation 4, you can easily cancel out C1L A by negative C1L, and you can easily see a 4 over 120 WL to the fourth minus 2 over 6 RAL cubed equal to 0. And you simplify the equation, it gives you RA is equal to 1/10 of WL. Mhm. And it's pretty interesting, you can see, because the bigger chunk of W is a more closer to B. So by simple Fi equation goes 0, you can easily get Rb is equal to 4 over 10 WL. So the total load should be half of WL. So Ra a handle a 1/10, and Rb handle the rest of the force, which is four times bigger than Ra. Mhm. And at the same time, so this is Ra and this is Rb. Mhm. And then if you replace the Ra in equation 4, which you already know it's 1/10 of WL, mhm, and that's W naught. So that's W, a, just for more clarification, that's W naught to the entire length. So if you do that, that just gives you the only unknown of the problem, which is C1. And if you do so, it just gives you C1 is a negative 1 over 120 WL cubed. Mhm. If you replace the whole thing in elastic curve equation and simplify the equation, it just simply give you this equation for elastic curve, and that's a equation of elastic curve from moment. Mhm. And if you just calculate theta, and that's dy over dx, and that's a just a derivation of a delta equation. So if it's this is x to the fifth, it could be 5x to the fourth plus 6 L squared x squared minus L to the fourth. Thank you.